Now let's examine this problem. This problem reads square root of 2x minus 5 times the fourth root of 2x plus 6 equals 0. Again, this should be a quasi-quadratic equation because with a suitable substitution we should be able to turn this into a quadratic expression. Now, the thing is, you probably don't like this fourth root, okay? Now, effectively, the fourth root, if we want, we could write that in an alternate form as 2x to the 1/4 power. And likewise, this is the square root, so that is 2x to the 1/2 power plus 6 equals 0. Now, we really want to replace that expression. So we want u to equal something of the 2x, but do we want just the 2x? Because then if we just let u equal 2x, then you still have u to the 1/2 and u to the 1/4. So the idea would be to let u equal the lowest of the terms. Let u equal 2x to the 1/2 power. I'm sorry, to the 1/4 power. That's the lower of the two terms. Now, so if that's the case, then that becomes 5u plus 6. Now, you should suspect that this should become u squared, and in fact it does, because if you ask for u squared, then you're essentially saying it's 2x to the 1/4 power, then raised to the second power, which we make u squared equal 2x to the 1/2 power. Okay, so then that stands as u squared, and there we are, quadratic equaling 0, nicely factorable into u. This would give rise to what? U minus 3 and u minus 2 equaling 0. And saying that u would equal 3 and u would equal negative 2. I'm sorry, u would equal positive 2. But now we have to remember what u was. Okay, so u we let stand for 2x to the 1/4 power, collectively to the 1/4 power. We're going to say that's equal to 3. Likewise over here, we're going to say, yeah, u, which is 2x to the 1/4 power, is equal to 2. But we don't like the 1/4 power, so we're going to take that, 2x to the 1/4 power, and then we're going to subsequently raise that to the 4th power, which we'd have to do on the other side since we have to keep the equation in balance. Now, solving that, then you should see that you should agree that this simply comes to 2x. And 3 to the 4th, you should know, 3 squared is 9, 3 cubed 27, 3 to the 4th is 81. And of course, x would be then, okay, 81/2. All right. Now, what happened to that? Let's bring it back. Okay. Now over here, then again, you're going to take this 2x to the 1/4 power, and again, you're going to raise that to the 4th, but likewise raise the other side to the 4th power, 2 to the 4th power, which you should know is 16. Over here, it's 2x, and that means x is equal to 8. Now, you really should check these, okay? Let's check one. Let's put the 81/2 in. So putting in the 81/2, you got 2 times 81/2, okay, which is simply 81, and you're taking the square root of that, which is going to be 9, minus 5 times what happens here, okay? So you're going to put 2, you're going to put 81/2 in again, and this is the 4th root, excuse me, which would be minus 5 times the 4th root of 81. Now the 4th root is the square root of the square root. So it's like over here we knew what the square root of 81 was. It ended up being 9. Now we're going to take the square root of that. That's the square root of the square root, which will collapse that to 3. which make it 9 minus, well, it's going to be 5 times 3 now. Okay, and then looks like we're in balance. Okay, so we got 9 minus 15 plus 6, that is equal to 0. So 81/2 seems to be a viable solution. I would suggest that you try the other one as well to see whether or not that is an acceptable solution. Okay, and there is our. Let's stop that, and you can look at that video. Looks like we weren't recording that at all. Okay, well, that's the end of that one. Hopefully you get that straight, all right?